Hello everyone, you are looking at a stunning 4K view captured by NASA's Curiosity Mars rover, revealing 4 distinct geological layers that the mission was set to explore, and beyond them, the towering upper slopes of Mount Sharp. On the picture, you will notice helpful markers. A dotted white line traces the upper edge of Vera Rubin Ridge. A small red dot shows Curiosity's planned route to climb the ridge. And scale bars offer size reference. The nearest bar, measured in centimeter, refer to patch of ground 90 feet from the rover. The others, in meters, point to terrain 900 meters away on the ridge, and even farther 3.4 kilometers or 2.1 miles in the sulfate unit. These layers are more than just scenery. They tell a story of Mars' environmental evolution and possibly its ancient habitability. Just beyond, toward the footage, those clay grey rocks belongs to what's known as the clay unit. Sandwiched between these two zones is a narrow, elevated band of terrain called Vera Rubin Ridge, appearing darker and slightly textured. Further in the distance, those rounded brown knobs, they are part of the sulfate unit, an area rich in mineral salts, pointing to a history of water on ancient Mars. And beyond that lie the even higher and still mysterious reaches of Mount Sharp. The panoramic view is stitched together from 6 images taken by Curiosity's Mast Camera on the 1589th Martian day, also known as Sol 1589. At the point, the rover was still over a kilometer away from Vera Rubin Ridge, positioned just north of a spot called Ogunquit Beach, marked on NASA's official Mars terrain maps. The ridge itself holds special meaning. It was informally named in early 2017 in honor of Vera Rubin, the astronomer whose work helped uncover one of the universe's biggest mysteries, the presence of dark matter. So let's take a closer look at the fascinating geological features of Martian rocks and sand. The panorama has been white balanced so that the colors of the rocks and sands appear as they would under daylight here on Earth, helping us better imagine what it would be like to stand right there beside the rover. Are these the remnant of geological history, or could they be something more? The red planet continues to keep its secret well hidden, but every image, every footage brings us one step closer to the truth. In the foreground, the deep red terrain belongs to the Murray Formation, a region the rover has studied extensively. What you are seeing now is one of the most fascinating 360-degree panoramic view captured by Mars rover. This sweeping vista looks out over a stretch of the Beagnol Dune, a massive field of dark, wind-sculpted sand that extended for several miles across the Martian surface. Now what you are seeing is not ordinary. The frame reveals something far more intriguing than barren Martian soil and lifeless rocks. Look closer. In this frame, we see fractured slabs of ancient bedrock, part of the Murray Formation, but within them lies something different, something unnatural. Inside the white circle, could that be a sign of erosion? or something else. You will also see parts of the rover itself, quietly stationed at a location called Ogunquit Beach on the northwestern flank of Mount Sharp. From February to April 2017, Curiosity investigated 4 sites along these liner dunes, comparing them with earlier observation of crescent-shaped dunes made between 2015 and 2016. This two-phase campaign marked a historic first, the first close-up study of active dunes anywhere beyond Earth. Now shift your focus here. Amidst the endless ripple of dark sand dunes, stand a solitary vertical object. It is not a shadow, it is not a random rock. Its form is striking. Narrow, upright tree-like, a dried trunk, or something else entirely. Zoom in, it becomes even more puzzling. Weathered branching, rising from the sand like a relic from another time. Scientists call it erosion, but is that all it is? At the center of this panorama, you can spot a dark, rippled liner dune descending into the distance. In the foreground, layered and time-worn, lies the Murray Formation. Bedrock formed billions of years ago from sediments that settled in ancient Martian lakes. This is a full circle image. Northwest is visible at both edges of the frame. Southeast is centered, where the majestic slope of Mount Sharp rises into view, dominating the horizon. If you look closely, you can see the contrasting textures of the terrain, the fine ripples of the dune, gravel-strewn ground, and the sediment-rich bedrock in the foreground. All of it provides scientists with clues about Mars' dynamic wind patterns. This dunes campaign isn't just about surface beauty, it's helping answer important questions. How do Martian winds shape dunes into different forms? Do these winds sort grains of sand by their mineral makeup? And what might that tell us about how Martian sandstone formed over time? This remarkable panorama is made from 115 individual images, all captured by Mast Camera's left eye lens on the rover's Sol 1647. In this next visual, we can see a gleaming, toned sheet of metallic foil, shiny, sharp, unmistakably artificial. Debris from a mission? Perhaps. But what's more bizarre is what lies beside it, something that looks like a coil or spring on Mars. Not nature, not weather, not geology. All these elements scattered across Martian landscape invite questions we are not yet ready to answer. But friends, here I would like to share that according to NASA, it's a heat shield of opportunity Mars rover. By the way, what do you think? Leave your opinion in the comment section below. And if this video made you curious or gave you a new view of Mars, so please like, share and subscribe to Space Truth.